Okay, for the next set of examples, to find our trig ratios of sine, cosine, and theta, what we have to do is we have to find the missing side first. We have to find this missing side here. So what we have is a squared plus b squared equals c squared. So 2 is the hypotenuse, so you have 2 squared. So we know that 2 is the hypotenuse, so we have 1 squared. So a squared plus 1 squared equals 2 squared, so we get that's 1, that's 4, so a squared equals 3. So a is the square root of 3. So now we can go back and we can replace this side with the square root of 3. And then we just label our sine, which is opposite over hypotenuse. So the opposite is the square root of 3. The hypotenuse is 2. Cosine is adjacent over hypotenuse. Adjacent is next to this, so the adjacent side is 1. The hypotenuse is still 2. And the tangent is opposite over adjacent. Opposite of our angle is the square root of 3. The side adjacent to our angle is angle 1. So that's how we get these three trigonometric ratios. So once again, we look at the second example B. So now, once again, we have to find our Pythagorean theorem. So it's a squared plus b squared equals c squared. We plug our values in. So it's a squared plus 1 squared equals 4 squared. A squared plus 1 equals 16. 1 squared is 1. 4 squared is 16. So a squared, subtract 1 from both sides, is 15. So a equals the square root of 15. So that's how we get that side there. And now we do our sine, which is opposite over hypotenuse. So sine is opposite over hypotenuse. So opposite the angle is our square root of 15. Hypotenuse is 4. Cosine is adjacent to the angle over hypotenuse. So adjacent to the angle is 1. Hypotenuse is still 4. And tangent is opposite over adjacent. The opposite side is the square root of 15. And the adjacent side is 1. So that's how we get these three ratios. So we have to find the missing side using the Pythagorean theorem. So once again, with this last triangle, this time we are looking for the hypotenuse. So when we have a squared plus b squared equals c squared, it's 2 squared plus 3 squared equals c squared. So that gives us 4 plus 9. And we know that 4 plus 9 is 13. So c is the square root of 13. So if I'm going too fast, just pause it and copy this stuff down and go back. So that's how we get c. So we know that the hypotenuse is the square root of 13. So sine, opposite over hypotenuse. I write it down every time so I make sure I get these right. So the opposite, so here's my angle. Opposite is 2. Hypotenuse, we said, is the square root of 13. Cosine is adjacent over hypotenuse. My angle, adjacent to the angle, is 3. And the hypotenuse is the square root of 13. And the last one is tangent. So tangent is opposite over adjacent. Opposite, once again, is 2. Adjacent is 3. And there's my three trigonometric ratios. So moving on to the next page. Alright, so if we consider the drawing of a small triangle inside a large triangle, the small triangle is the side opposite the angle theta, which is 3 units, and the hypotenuse is 5. Therefore, when using the small triangle to calculate the sine of theta, we get the sine of theta is opposite over hypotenuse. So when we look at it, if we know that the hypotenuse is 5, so opposite is 3, hypotenuse is 5. So we get 3 over 5. And then if we look at the larger triangle, once again, we're going to get 9 over 15 because the opposite is 9 and the hypotenuse is 15. Now if you actually think about these, they're really the same number because this is the fraction 0.6 and this is also the fraction 0.6. So it's essentially the same exact sine of theta, which is 0.6, and the angle is the same for both of those triangles because they're similar, and we know that similar triangles the corresponding angles are congruent. So some facts about this. The cosine of any particular angle is always the same regardless of the size of the triangle. And the tangent is also always the same. So it doesn't matter how big or how small the triangle is, the sine, the cosine, the tangent are always going to be the same. So if we look at these next sets, so answer these questions by referring back to the figure in angle 6. So if we look at this, so if we know 3 and 5, we should know that this side is 4. All right, it makes a 3, 4, 5 triangle. So that's our small triangle. It's 3, 4, and 5. So for this, I'm going to draw my triangle right here so I know what it is. So I don't have to go back and flip back. So there's my triangle, 5, 3, and 4. And our angle that we were given is down here. So that's our angle. So to calculate the cosine, it's adjacent over hypotenuse, which is 4 over 5. And then the larger triangle, so once again with my large triangle, so what we had was, we were given that this was 15 and this was 9. Now if you notice that it has a scale factor of 3, so that's going to be 12. So 3 times 3 is 9, 5 times 3 is 15, so 4 times 3 is going to be 12. So our cosine of the larger triangle will be 12 over 15. And what do you know about 4 over 5 and 12 over 15? They're the same. Alright, they both give you 0.8. And then we can do the same thing for tangent. So tangent for the smaller triangle is opposite over adjacent, which will give us 3 over 4. And opposite over adjacent will be 9 over 12. And we notice that these are the exact same thing also. They're the same because they both give you 0.75. So if we look at this, alright, use a smaller triangle to find sine of theta. So what we know is that we're given 5 and 10, 24, and 26. So we have a smaller triangle, so they have a scale factor. This is half of this. Alright, so this side is going to be half of this, so that's 13. And 24, well, half of 24 will give us 12. So now we have our measurements for our smaller triangle. So what we can actually do to find these is, I'm going to get my graphing calculator, so give me 1 second. Okay, so I have my calculator back up. So we can actually find the sine here. So if we look at this, so sine, let me just, sine, our sine is opposite over hypotenuse. So opposite over hypotenuse is going to be 5 over 13. So what I can actually do is go to my calculator, and I have a button right here for sine. So if I push sine, well, first thing I have to do is go to my mode, and I have to change this radians to degrees. So I want to find the degrees. So, because whenever we talk about these, finding the sine, finding the inverse sine, it'll be in degrees. So what we do, okay, to find the actual measure, so we want the sine of this, of 5 over 13. So I actually, here's my button for sine. So I actually do this second sine. It's going to give me the inverse. It's going to give me the degree measures. So the inverse of 5 divided by 13 will give me this 22.6. So that I know this angle here, this angle is actually 22.6 degrees. And then we can look at the larger one. So you look at the large triangle. Well, sine of the larger triangle is, the sine of the larger triangle is going to give us 10, opposite, 26 or hypotenuse, so 10 over 26. And now if we do that same process, so the inverse sine of 10 divided by 26, and I'm still in my degree modes, gives me 22.6. So notice how they're the exact same thing. So they're the exact same thing. And then we can look at the cosine. So we can do this to figure out what the cosine is. So the cosine, so now when we look at it, so cosine is adjacent over hypotenuse. Well, the adjacent side, 12 over 13. So if I take a look at my calculator, and here's my cosine button, so I take the inverse cosine because I'm trying to find the actual angle measurement. So, alright, sorry. So we find a cosine of 12 divided by 13, and that gives me 22.6. So once again, it's the same thing because I'm finding the same exact angle. I'm just using cosine because it depends on what you're given in the problem to figure out which of these you can use. So the cosine of the larger triangle, it's going to be 24. The long side over the hypotenuse. So 24, the adjacent side over 24 over 26. So once again, we can do the inverse cosine. 24 divided by 26, and it gives the same exact thing, 22.6. So if we find a tangent, it's going to be the exact same thing. So it's still going to give us, all these will give us 22.6 degrees. So finding tan 45, so what we want to do here is, so find tangent 45 using each actual size figure. So now what you should notice, see how these are 45 degrees, 45 degrees, 45 degrees. Well, what do you notice about the opposite and the adjacent? Alright, opposite over adjacent is going to be 1 over 1. Opposite over adjacent is going to be 1.25 over 1.25. So opposite over adjacent is 2 over 2. So when we're talking about tangent 45, the opposite and the adjacent are the exact same things.